Hello students, welcome to the session on Castigliano's theorem. So we are going to analyze this bent frame, determine horizontal deflection of free end. So I have to find for the given loadings what is the horizontal deflection of point D. So again the same case I am going to draw a same frame. For this frame apply the given loads 50, 30 kilonewtons per meter. Next, I have to find horizontal deflection of point D. So what I am going to do is, I am going to apply a load like this, a load in this direction. Let this load be Q. Now I have to make these sections. So I have to analyze part by part. So I am going to take first section like this, second, third. Again same, since there is no point load at point D, I am applying a dummy load. Apply dummy load at point D in horizontal direction. Now put the table and write the values. So first DC, CB, BA, origin, limits, momentum, EI. So for DC, just look at the section here. At this point, again to find out whether it is positive or negative, I am simply going to draw a dotted line on the inside. Any force which produces tension on the dotted line is taken as positive. The force which produces compression on the dotted line is negative. So for this force, this produces compression on inside because this is going to bend like this. It is going to bend like this. This outside will be tension, inside will be compression, and my dotted line is inside. So inside it will be negative. So origin is D, limits 0 to do, momentum minus Q into X, EI. Now come to portion CB here at this section. Consider only this much, forget this part. Now at this point, at this section, two loads Q and 30 both are acting, and again both are producing negative moments. Hence this will be minus Q into this distance, and that distance is 2 meters, this distance, and W into X by 2, or load into span into CG distance. So origin is C, limits 0 to 4, so minus 2 into Q minus load is 30, span is X into X by 2, 30 into X by 2, 30x square by 2, or 15x square, EI value constant. Now BA at this section, three loads are there. One is this dummy load Q, UDL, and this point load. So I have to consider all three. This is acting in this direction, again compression on dotted line. This is acting on this side, and compression, this also produces compression. So all three forces are negative moments. So first this minus of origin is B, limits 0 to 2, next minus Q into 2 minus X, so that whole section is considered. Next, because of UDL, load into span into CG. Load is 30, span is this whole span 4 Cg is 2. So 30 into 4 into 2. So I get the answer minus 120. Now this load 50. 50 into x minus 50x. Actually this is load into span into Cg. This is 240 minus 50x EI. Now we'll start with the equations. Strain energy U is 0 to L m square by 2 EI. So first for first term 0 to 2 m square. So everywhere there is minus, I am going to take that outside. M square q into x bracket square. Q square x square by 2 EI dx plus 2q plus 15x bracket square 0 to 4 2q plus 15x bracket square, actually 15x square divided by 2 EI dx plus again minus outside the bracket. So 0 to 4 q 2 minus x plus 240 plus 50x whole bracket square divided by 2 EI. Now go on differentiating the terms. Dou u by dou p. What differentiation, partial differentiation means is we keep the integration terms and we integrate only the terms which are having p. So differentiate the terms which are having q, actually dou u by dou q with respect to q. So here 0 to 2. So differentiation of q square, dou by dou q of q square. So this is 2q into x square by 2 EI plus 0 to 4. Here for this term 2 into this bracket as it is, then differentiation of only this term. So 2 into 2q plus 15x square, then differentiation of 2q with respect to q, that gives me 2 by 2 EI dx plus 0 to 4. Again here it is whole bracket square. So first 2 into this whole bracket as it is. 2 into q 2 minus x plus 240 plus 50x. Now differentiation with respect to q, this term here there is q is there. So d by dq of q into 2 minus x. So this goes, only this much portion remains. 2 minus x divided by 2 EI. Now since there is demi load, substitute q is equal to 0. So dou u by dou p is equal to, this is 0, here this term becomes 0, here this whole term becomes 0. So I am left with 0 plus 0 to 4 30x square. This and this gets cancelled. 15 to the 30. 30x square by EI dx plus 0 to 4 here 240 plus 50x 2 minus x. 240 plus 50x 2 minus x divided by EI dx. Now I have to solve this bracket first. Is equal to integration of 0 to 4 30x square by EI dx plus, first let me solve this bracket. 240 into 2 480, 0 to 4 480 I've done this. Then 50x into 2, 100x, 240 into x, so minus 240x, 100x minus 240x, so minus 140x, 140x minus 50x into minus x, minus 50x square divided by ei dx. Now start with differentiation. 30 by ei, start with integration. Integration of x square, x cube by 3, 0 to 4, plus 40 by ei, or 480 by ei, only 1 remains, so x 0 to 4 minus 140 integration of x square. Integration of x is x square by 2, 0 to 4 minus 50x square. 50 into x square is x cube by 3, 0 to 4. So solving this, we have delta D horizontal as 373.33 by EI. So EI values are given. So EI is 12 into 10 raised to 13 Newton mm square. I have to convert that into kilonewton meter square. 12 into 10 raised to 13. 1 Newton into kilonewtons is 10 raised to minus 3 into 1 mm, that I have to convert into meter, into 10 raised to minus 3 bracket square. So this gives me 12 into 10 raised to 3 kilonewton meter square. So substitute the values here. Delta DH is equal to 373.33 divided by 12 into 10 raised to 3. So we have the answer 0.0031 meters, and that is equal to 3.1 mm. Thank you. This completes the problem. Thank you.